Hi everyone, this is A Navin, rule number 49, and my topic is about object oriented web application development. Here we see the contents of the presentation. In this, we observe the definition of web application, how web applications, functions of web application, advantages of web applications, comparison between server-side scripting languages and client-side scripting languages, and web security concerns, recommendations for security, and references. First of all, we see the definition of web application. Web applications are computer programs which allows website visitors to submit data to a database or retrieve data from a database over the internet using web browser. The data is then presented on browser as information is generated dynamically. Here we see the how web applications are work. In this, we see the client side browser and server side browser. In client side browser, we see the company website visitor, and in server side browser, we see the web servers, web application servers, and some of the database services. And in between these, the internet will be presented to operate these client side servers and the server side servers. Functions of web application: display records stored in database, shopping cart for saving products, creating and managing profiles accounts, uploading images or files to the database and retrieving them for database, web content management systems. Here we see the advantages of web applications. The development of web applications is cost effective. Web systems are accessible anytime, anywhere via PC and mobile phone with an active internet connection. The user interface UI of web-based applications is easier to customize. Contents of web applications can be customized for presentation on any device connected to the internet, including PDS, tabs, mobile phones, and etc. Installation and maintenance of web applications are less complicated. The application will run on the browser regardless the platform. No installation of software required. Many web apps are providing chat room facilities and the ability to share work in real time. The support and maintenance of web applications require low cost. Comparison between the server-side scripting languages and the client-side scripting languages. Here we see the comparison between the server-side scripting languages and client-side scripting languages. In server-side scripting languages run on the server, and in client-side languages run on the user machines. The examples of server-side is PHP, Ruby, ASP, Net, and Perl. And the examples of client-side is JavaScript, Dart, and Python. In server-side scripting is used for building dynamic pages based on some conditions when the browser makes a request to the internet. And in client-side scripting is used when the browser already has all the code and the page is altered on the basis of the user input. Server-side scripts are affected by the processing speed of the host server, and client-side scripts are affected by the processing speed of the client or user's computer. The web server executes the server-side scripting that sends the page to the browser. And in client-side, the web browser executes the client-side scripting that resides at the user's computer. And here we see the web security concerns. There are some security concerns of applications that should be kept in mind before going on to make a web-based system. Cross-site scripting XSS. Cross-site scripting SSS is a execution of scripts in the victim's browser for hijacking information. CSS allows hijacking user sessions, defecting websites, etc. The reason the reason behind this flaw is inappropriate validation of user supplied data that an application takes and sends to a web browser without encrypting and validating the content. Injection flaws. Injection flaw is a common threat of web application, especially SQL injection. Injection occurs when the user supplied data is sent to an interpreter as a part of a command or query. Attackers can trick the application into changing system data or executing unintended commands. Malicious file execution. Remote file inclusion RFI gives hackers the chance to inject hostile data, resulting in an incisive attack such as a compromise of the server. Malicious file execution attacks can be on XML, PHP, or any framework that receives files from users. Insecure direct object reference. A direct object reference occurs when web application developers expose any reference to a private implementation object. Example, a file database record as a URL or a form parameter. In this case, attackers could change the insecure references to enter another object without authorization. Cross-site request forgery. Cross-site request forgery CSRF is a big problem as it can be as strong as of the web application that it attacks. It might force the browser when a user is logged in to transfer a pre-authenticated request to a specific vulnerable web application. The application then pushes the victim's browser to execute a hostile action that benefits the user. Recommendations for security. Some recommendations for making strong and secured web applications. Validate all input parameters. A central module should be developed to validate input parameters and check every input parameter against a distinct format that specifies which types of input exactly will be allowed. Special characters coming from the input form also should be filtered. Sanitized application response. A central module should be developed to execute any sanitization. All outputs and error codes should be tested to ensure that the processing actually occurred as is expected. For instance, unnecessary core system information such as error messages generated by internal server errors during a response must not be visible on the client side. Most web servers allow to generate custom error page when any internal server error occurs. Hypertext Transfer Protocol trust issues. Web application programmers should not trust from fields HTTP referrer, headers or cookies for security decisions. Since this type of data can be compromised, these parameters coming in from a client's browser is not reliable without using the robust cryptographic techniques to verify the integrity of Hypertext Transfer Protocol headers. Keep sensitive session values on the server. Storing sensitive information is a client browser cookies is not good practice. The sensitive information should be kept on the server if there is a need to store sensitive values in a client browser. Powerful cryptographic techniques should be used to protect the privacy of the data. Encrypt sensitive pages. The pages having sensitive information must be encrypted during the transmission with proper algorithms and keys, such as SSL and TLS. To attain and show sensitive information, signed Java applets or ActiveX can be used. Session management. Session management plays an important role on securing website. The session ID must be complicated, long, and contain random, unpredictable numbers. The session ID also should be changed repeatedly during a session. It makes the session ID complicated to find by reducing the duration that a session ID remains valid. Furthermore, a session ID must not be stored in a persistent cookies, URLs, HTTP headers, or hidden HTML fields. That's all about my topic. Thank you.